Good evening. Welcome back. Here we are now on Notes for Slope 14-3. I would have you go ahead and take out your Topic 14 vocabulary sheet. There is a vocabulary word for slope of the line. Oops, that didn't quite work. Pardon me. Slope of the line that you need to go ahead and fill in. Go ahead and pause the video. So the definition states that the slope describes the steepness of lines in the coordinate plane. That's your x and y axis. The slope of a line is the ratio of the vertical change to the horizontal change. So you might remember in Miss Dempsey's class seeing something along the lines of a triangle, meaning change. So the vertical change, well, vertical is your y-axis, so that's your change in y. Divided by your horizontal change would be your x-axis, so your change in x. So you're going to have that in there as well. When I think of slope, I think of skiing, going on a mountain, in steep slope. I definitely would not want to go down a black diamond because that is going to be very steep. I would like to go on more of a lower slope because that would be easier for me. So they have, again, really you can think about slope in three different ways, as I have all three listed here. As a vertical change written this way, rise over run is another way to think about it, or even just writing change in y over change in x. So looking at the graph, they have them starting at the coordinate 0, 0. We look where the coordinates are plotted. They are showing that it is a rise up of 3 units and a run going to the right of 2 units. And then they continue that pattern and see it rises up and rises over. So 3 halves is your slope of your line. Notice though the slope of the line 2 is also an improper fraction. It is okay if your slope is improper. It actually wouldn't really make sense if you changed it to a fraction or a decimal. Example number 1, we're going to go ahead and identify the slope of these 3 lines. They're giving us a couple examples of here what they could be. They have already for us, which is very nice, plotted the points for a couple of these. So for the first one, if we start off at 0, 0, rise up until you get to the same line grid as where the other coordinate is. You're making a right angle here. You don't have to actually draw the right angle in. You're going to count up that we rose up 2, and then we ran over 3. So your slope would be 2/3. Because again, you're thinking change in y divided by change in x. For the second one, again, I'm starting this time though at -2, -2. I didn't go through the origin, and that's okay. I'm going to rise up, and then go over to the right, run over to that point, and I will count 1, 2, 3 going up, and 1, 2, 3, 4, 5 running over to give me 3/5. Then if I notice the difference between the third example is that this one is going down. The other two are going up. So let's think about if this was going up, that gave me a positive slope. If this is going down, this is going to give me a negative slope. That's the only way here that I know that I'm actually going to get a negative slope. So instead of you're rising, you're really going down, but the running is still the same. So since I went down 1, that's why I have a -1 there, and then I ran 4. So that's where I'm getting the -1 from, because I went down instead of going up. Go ahead, look at example number 2. Pause the video, give that one a shot. And here I have my answer of 2 first or just 2. It's okay to have a whole number as your slope. Turn the page to example number 3. This one's got a little bit more of a word problem to it. It says that one of your friends describes the slope of a line as the x-coordinates increase by 2, the y-coordinates decrease by 5. Your other friend describes the slope of a line as the x-coordinates decrease by 2, the y-coordinates increase by 5. Is it possible for your friends to be describing the same line? Of course, then it says explain. So I go back and I read the statement where it says that the x-coordinate increases by 2. That means that my x is going up by 2, And if I then have the y coordinate decreases by 5, that's telling me that the y coordinate goes down by 5. Then the other friend says that the x coordinate decreases by 2. So x decreases by 2. And the y coordinate increases by 5. So that'll be y increases by 5. And at first glance, it might look like your friend is still describing two different lines. But if I now think about the change in y over the change in x, for the first friend, the negative 5 is going down, so I put the negative sign to show that, divided by 2. Then I can rewrite this if I want. You don't have to, but if you want to have that negative hanging out right in front of the fraction, that's the exact same thing. Then we have our second friend who had 5 positive divided by negative 2, which is also, again, the same thing as negative 5 halves. So is your friend describing the same line? Yes. And I think the math is explanation enough. So then we have the key concepts to focus on. And again, if you ever at any time want to pause the video to get an extra little dose of what I'm reading, you can certainly do that. So the key concept here says you can find the slope of the line by subtracting the coordinates of any 2 points on the line. The first y coordinate you use for the rise must belong to the same point as the first x coordinate you use for the run. That's really important, and I understand that sentence might not make sense right now, so I'll show you an example later explaining that a little bit more. So when I kept saying change in y coordinates, change in x coordinates for slope, what that means is you actually are going to be subtracting. So they're showing us right here the change in y divided by the change in x. But instead of writing the little triangle for change, they're writing it out. So what they did is they said, okay, we have to look at our y coordinates first. So remind yourself that your coordinates are always written in x, y, with parentheses around the coordinates. So they started with 3 as your y. So then that meant that obviously I'm going to subtract my y coordinates, so 3 minus 0. Then because they started with the 3 first, they have to start with the negative 4 first when they do their subtraction. Otherwise, we would get the wrong answer. So they started with the negative 4, then subtract negative 2. So 3 minus 0 gives 3. Negative 4 minus 2 gives you negative 6. Reduce that down to or equal negative 1/2. We'll do a couple examples together here. So I want to scroll down too far. Number 4, if you notice, there's no graph even here. They're just giving you the coordinates and expecting you to find the slope, which is totally doable. Number 4 is saying what is the slope of the line that passes through each pair of these points. So again, reminding ourselves that we have x, y coordinates. We're always thinking again in our head, change in y divided by change in x. That seems kind of familiar to me. The y goes over the x. Remind that for later. I'm going to start with this 2 here. So that means I will go 2 minus 4. That will stay, hopefully. Divided by negative 3. I have to start with the negative 3 since I started with the 2. So I have to start with the negative 3 first. So negative 3 minus 2. Just to remind ourselves, this becomes 2 plus negative 4. This is negative 3 plus negative 2. So 2 plus negative 4 is negative 2. Negative 3 plus negative 5 gives us, oops, I gave away the answer. Negative 3 plus negative 2 gives us negative 5. Negative 2 divided by negative 5 will give us positive 2/5 for our final slope. For B, again, I just like to start with this one first, because it's listed as the first pair of coordinates. So I have 1 minus, don't just write 5 here and think that you already put the negative sign. You are finding the change, so that means change, subtract. So if this is a negative 5, I have to make sure I include that in there. Then, again, since I started with the 1, I have to now start with the 6. So that'll be 6 minus 8. If I rewrite this, it becomes 1 plus positive 5, 6 plus negative 8. And we'll get 6 divided by negative 2 to end up at negative 3. If you want to put it as negative 3 over 1, you certainly can, or just leave it as negative 3. I know over is not the technical term, so I should say divide. We'll finish up with C. It's going to be 4 minus 4, then negative 2 minus 1 equals 0 divided by negative 3. 0 divided by negative 3 will give me 0. Go ahead, look at number 5, and pause the video. Hopefully you guys were able to get negative 1/6 as your answer. What I am doing for you here is in the black, I am showing that if you chose to use the negative 3 first, what your slope would come out to be. And then in the blue, I am showing you if you said, I want to switch the order and I want to start with the negative 2 instead. Pretty cool here. The answers both come out to be negative 6. And that's the fun thing about math. So if you don't have to have both ways, I just wanted to show you in case you had done it the other way. On to the next page, number 6. This is a new word here. The line shown has an undefined slope, and they want us to use the points shown to explain why. So at first you might be saying, gee, that's a pretty steep line right here. So we might be thinking, that has a really high slope. But what we're actually going to figure out in a second is that it is undefined. Again, change in y divided by change in x, keeping that in our minds here. We're going to take the 3 from here, not the 3 from the first x coordinate, minus 1, and the 3 minus 3, and we get 2 divided by 0. 2 cannot be divided into 0 groups, so this is an undefined statement. And we've talked about this before, but if you don't believe me, you can take your calculator, hit 2 divided by 0, and error should pop up. For the next key concept, you are going to need to do a little writing. You want to make sure, too, that if you have a highlighter or a different color pen, that you take that out right now because it gets kind of confusing trying to find the difference between your coordinate planes and the lines. So I'm going to go ahead and draw my coordinate planes in one color. You can do this with me as well. Coordinate planes, we want to remember that we need to have arrows because they show continuing lines. So I'm going to draw 4 coordinate planes here. It's also a good idea to label your x and y axis just for practice. Never hurts. And then this is where you want to pick up a different color, so you want it to stand out. So a positive slope states that it is a line that slants upward from left to right. So starting at the left, I want to be going up. So imagine walking up a pair of stairs. So I'm going to go up like this. That's not a very straight line. Just imagine that it is. Notice that it does not have to go through the origin. It just has to be a straight line on your graph. Next, a line with a negative slope slants downward from left to right. So now we think about descending down some stairs. So if I was descending from left to right, I would look something like this. Again, drawing the arrows to show my line is continuous. For a 0 slope, well, 0, that means that there would be no rise because it's the rise divided by run. So 0 rise. A 0 rise then would mean a horizontal. If I was running in a marathon, I would definitely want to have slopes of 0 because I wouldn't want to be going up the hills. Then undefined slope we just talked about is a line that is slope is vertical. So again, where you want to draw that in. Number 7, at first, just by looking at the diagram, you're saying they are only giving us 70 inches and 8 inches. Also, they're not giving us a graph, so it almost looks like there's not enough information. Well, let's start by reading the question first. Number 7 says the building code for a ramp recommends the ramp should rise no more than 1 inch for every 12 inches of length. Definitely think about that for like handicap ramps. You don't want the wheelchairs to be going on a really sharp, steep decline because then they would just go off rolling. So does the ramp shown meet the building code with this path? How do we know? So again, this is a straight line right here. And I know that this isn't really, they didn't give us the coordinates of these points that I'm plotting here, but when we have the two coordinates on our graph, we just are really comparing about what the rise and the run are. And so that's what they've given us. This is the rise, and this is the run. So that would be 8/70, which I can change to a decimal, and I get approximately 114 thousandths. So the building code, though, states that it should rise no more than 1 inch for every 12 inches of length. So the rise goes in the numerator, and that will become, oh, and I'm repeating decimal, make sure I write it correctly here. And clearly looking at the two, if I was to compare these two numbers, I would see that the current ramp that is drawn, this was for the ramp, is definitely larger than the building code. So I would say no, the slope of the ramp is greater than the building code. Almost there. Last example, number 8. Go ahead, give that one a try. Pause the video. I got that roof B will be steeper because roof A had a slope of 1 71/100. Roof B had a slope of 2. Since 2 is greater, my answer will be roof B. Thanks for watching. We'll see you again soon. Bye.